Want to do secant?
Yeah, it really isn't.
Okay, let's do secant. So let's make up a problem. Y equals
3.
Come on, Professor.
2 secant.
Y equals 2 secant.
What do we have to do?
Give me a number.
4.
4.
Plus pi over 5.
Okay, let's make it. How about we make it? Do ourselves a favor. Make it pi over 8.
Okay.
We can do pi over 5. Last time you did it, last time you gave us 1. What did you give us? Over 23 or something horrible like that? We ended up with prime numbers. Let's do pi over 8. So we want to graph this. Now here's what I think is the quick and dirty, cheaty way to do this, which I think is the smart way and makes life happy. Okay? I say, I want to know where this is undefined. I want to know where I'm going to have a problem. So I say, where do my asymptotes happen for secant? Forget this gobbledygook here for a minute. Okay. When does secant become undefined? Secant is 1 over cosine of theta. So when cosine goes to 0, that's where I get my asymptote.
So pi over 2.
Yeah, so this is pi over 2, right? So when theta is pi over 2, that's when I'm going to have a problem. So if I look at this, mess here, when this equals pi over 2, I'm going to get an asymptote because it's secant. So let's just set it equal to pi over 2 and solve it. So I'll say 4 times. I am going to go ahead and multiply the, actually I don't even need to multiply the 4 in this time. We have 4 times theta plus pi over 8 has to equal pi over 2. So if I divide this by 4, what do I get?
You have pi over 8.
I have theta plus pi over 8 equals pi over 8.
So
Theta equals 0. That worked out nicely. So where do I get my first asymptote, or at least an asymptote? I get it at pi equals, at the theta equals 0. That's convenient. So if here's my axis, this is an asymptote. My y-axis is my first asymptote. Then the next thing I ask myself is, what's the period of this function? What's the period of secant if you don't mess with it?
2 pi.
It's 2 pi. What's our formula for period?
2 pi over k.
It's 2 pi over k. And in this case, k is 4.
Yeah, pi over 2.
So every pi over 2, I'm going to have to get another asymptote. So I'm going to get an asymptote at pi over 2. I'm going to get an asymptote at negative pi over 2. You see why I like graphing these? For all the other 4 functions, you get an asymptote. All you have to do is set this to what causes your discontinuity. You get your first asymptote. Then you just calculate the period. Did I have to worry about the phase shift? Did I have to say, oh, wait a minute, I've got to pull this so many units to the right or left? No, because I'm graphing the asymptotes. And all of my graphs are going to get wedged between them. Over here, I had to say, oh, okay, wait a minute, I got to pull this to the right. That moves the axis to the left. This is harder. This, boom, you put the asymptotes down, you're done. Now, okay, I'm going to ask this. Listen carefully. What is the amplitude? There is no amplitude.
So what's the 2 do?
The 2 is just a multiplier. It doesn't have a fancy name. The only thing which has an amplitude is what?
Sine and cosine.
Sine and cosine, because it's a bounded function. All of the rest of the trig functions go to infinity, so talking about an amplitude is silly.
So what is the 2 do?
It's a multiplier. Instead of having the u more relaxed and fat like this, it makes it go up faster, makes it thinner.
Okay.
But it's not an amplitude. So if you are asked on the test, what is the amplitude of this tangent function? It is a trick question. Say, ha ha, I will not be fooled. There is no amplitude. You're allowed to do that. You can even stick your tongue out then. Yeah.
So would the phase shift, would that be like pi over 8?
In this case, the phase shift is pi over 8.
Just pi over 8?
Yeah, no, it's going to be pi over 8 negative, in the negative direction. It's the opposite of whatever this is.
Oh, yeah.
Now here's the thing, Emerson. Why I like this is because I have graphed my asymptotes. I don't care what the phase shift is. I don't care. And the reason I don't care what the phase shift is when I'm graphing this is because once I have the asymptote in place, I know my little U-shaped things have to go between it. So what's the minimum value that this function is going to, well, what's the minimum positive value that this function is going to take? Okay, it would be 1 if it were just secant, but it's
2. Oh, so it's 2.
the minimum value is 2. Remember when we had our secant waves and we graphed them next to our cosine waves, they just touch when cosine reaches its minimum value here, they touch, and when it reaches its maximum negative value here, they touch. So the minimum value for positive value for secant is 1. The maximum negative value is normally negative 1. But we're multiplying that by 2, so we'll put a dotted line across here. 2 positive, 2 negative. And now I just need to figure out whether my first u is up here or whether my first u is down here, because we know they're going to alternate. So let's just check. Let's put in 0. Oh, we can't put in 0. That's our first asymptote. We want to go. I was looking at this. I said, we need to choose the midpoint. 0. No, 0 was one of our asymptotes. We need to put in pi over 4 because that's our midpoint. So that's either going to touch here or here. So let's put in pi over 4. So if we put in pi over 4, we have 2 times secant of 4 times pi over 4 plus pi over 8.
Which is 3 pi over 8.
Which is going to be, this is 3 pi over 8. Which is going to be 2 times secant of 12 pi over 8, or
1 pi, or 1 with
1.5 pi.
Yeah.
okay,
So
it's going to
3 pi
be
over 2.
it's going to be 3 pi over 2. So 2 secant of 3 pi over 2. Now 3 pi over 2, think of your unit circle. Is your cosine value positive or negative?
Negative.
It's negative. It's negative 1. So is my first u up or down?
Yeah.
It's down because it's a negative value.
It can't be on there. That's an asymptote.
That's an asymptote.
This is my minimum boundary.
Right.
Yes, you're graphing on
Oh,
an
thank you.
asymptote.
Thank you. Graphing on. I should extend it down this way. You're right. That is my y-axis. Let's label that. So it's like that. And then up here it's like that. And then we're just going to alternate them. Yes?
Wait, so what made it negative?
We know that it makes a U shape, and it's going to hit its minimum point here or its maximum point here, halfway in between. And this asymptote, which I kept forgetting was an asymptote, was at 0. And we knew we had an asymptote at pi over 2. So it's halfway between 0 and pi over 2. Pi over 4. So I know I'm either going to touch that point there or that point there. Which one is it? I don't know. Let's just plug it in. So when we plugged it in, we found out that we get 3 pi over 2. What's cosine of 3 pi over 2? Think of your unit circle. It's 270 degrees.
Oh, so that's
It's negative 1. So secant there is negative 1. So if secant is negative 1, negative 1 times 2 is negative 2. It's touching down. This one's touching down here. And once I knew that, then I just alternate them. Up, down, up, down, up, down, up, down. Do you get how to use the asymptotes to help you with this? Easiest way to do these is find an asymptote. Set whatever this is to a discontinuity. Figure out what the period is and just say asymptote, asymptote, asymptote. And then fill in the blanks. Yes?